with exam 3 material, which is chapter 5, 6, and 7. So today we're going to do the first half of chapter 5. All right, I'm going to give you an example here. So this is chemical reactions. So if we did this chemical reaction. We have solid sodium, liquid water, and I think I showed you this equation a few times, right? And we get sodium hydroxide.
Is it new topic?
Yep, this is chapter 5. And we also get hydrogen gas.
Chemical reaction.
Yep. All right, so the little s right here, when we have an s in parentheses next to a compound, or next to an atom, or next to anything, that tells us it's a solid, okay? If there's an L, that tells us it's a, and G is, and AQ is something else, right?
What's AQ?
It's AQ. AQ stands for aqueous. What is the prefix of aqueous? What does that mean? Aqua, water, right? This is a solution of water. Remember when we did this reaction outside? And did you guys touch the stuff? And it was kind of slimy? Okay? That was a water solution of sodium hydroxide. Okay? And we're going to talk a little bit about bases this unit, or this chapter, but we'll get a lot deeper in acids and bases very end of the semester.
AQ is water, aqueous.
Aqua, it's a solution of water solution. And we'll talk about solutions more in depth later. But that's what that means. Okay? The substances on the left of this reaction or this equation, we call this a chemical equation. So the substances on the left side of the chemical equation we call reactants. Does it make sense why we call them reactants? These are the two substances that react together, as we saw in this demonstration, right? Okay. The substances on the right side of the arrow, or in this reaction, we call products. The reactants react together and they produce the products. Make sense? And this arrow stands for yield, makes, produces. All those are kind of synonymous words. We good? We did talk about diatomic molecules, is that right? Okay. Do you know the 7 diatomic molecules? You need to know them. You need to know them for exam 2. H2, N2, O2, F2, Cl2, Br2, I2. Do you remember how to look on the periodic table and notice which they are? There's 7 of them. Yeah, so never fear ice cold beer if you like that one. It's a little different order than they are on the periodic table, but you can definitely use that. I like to say, okay, there's 7 of them. Starts on number 7. We draw a 7. And the 7th one is hydrogen, the king of exceptions, right? But you need to know those because if I say I produce hydrogen, it better be H2, not just H. If I'm reacting with oxygen, it better say O2, not just O. You with me? Because those diatomic molecules don't appear in nature alone. They're always bonded with another atom. Okay? Is this oxygen alone that's in water? No, it's with two other hydrogen atoms. So there doesn't have to be a 2 next to that one. The reason I'm saying that is because I get a few questions saying, hold on, but there's not a 2 right there, and that's okay. We good? All right, let's take a look at a different equation. This is just propane being burned in the presence of oxygen. We get carbon dioxide and water. Okay. Anything look a little off with that equation? Missing hydrogens. We have 2 over here and we have 8 over here. According to the law of conservation of matter, we cannot destroy them. If we start with 8 hydrogen atoms, we got to end with 8 hydrogen atoms, and so on. Okay? So what we have to do is we must balance the equation. Never, ever, ever balance the equation by changing the subscripts in the compounds. Okay? If we change these, it changes what compound we're dealing with. We cannot change these. We cannot move them. We cannot get rid of them. We got to leave those as they are. So how do we balance it? By adding coefficients. You guys know what a coefficient is? So if I say I have 3x squared, what's the coefficient of x squared? 3. It's just a multiplier, right? You with me? So we have little blank spots on the left here of each substance that we could put a coefficient. What if there's no coefficient there? What coefficient is it? 1. Just like we write x. That means 1x, but we just write it as x, right? Same thing. Okay. All right, so according to the law of conservation of matter, however many carbon atoms we have on the left side, we have to have that many on the right side. However many hydrogen atoms we have on the left, we have to have on the right, and so on. You with me? So this is just, we count and make sure they're right, and if they're not, we put a coefficient in front. That coefficient goes to the entire compound. So if I put a 2 right here, how many carbon atoms do I have in this on the left side?
6.
We have 6, right? Because every one of these propane compounds, we have 3 carbon atoms. But if we have 2 of them, that means we have a total of 6. You following me? Easy way to do it is just 2 multiply 3. Woo. Right there. 2 multiply 3. How many hydrogen atoms do we have in that compound now that we have a 2 there? 16. Are you with me? Now, I didn't balance it out. I just put a number there. So let me give you, now, this is just a straightforward thing. You could just count and check, right? Put numbers there and make sure it's balanced. You don't have to know anything else besides that. I'm going to give you a few tips and tricks that will help you do this a little quicker and without pulling your hair out. Because sometimes you're like, oh, this one just doesn't work. And sometimes if it doesn't work, maybe you don't have it written correctly. So eventually, not today, we're going to learn how to predict the products. If we predict incorrectly, sometimes we won't be able to balance the equation. That's something that tells us, oh, maybe we wrote it wrong. Sometimes, if we write it incorrectly, we can still balance it. And that's a bad thing too, right? So we have to make sure we predict these correctly. We'll get there. So let me give you a few tips and tricks on how to balance equations. Again, if you don't remember these, you still should be able to balance these. It just might take you a little bit longer. Okay? If you count them and it's not the same, you keep going. If it's the same, you're done. Okay? Just remember to only add coefficients. Do not change the subscripts. All right, so some tips and tricks. Okay, first one, these aren't in, I'm going to give you these kind of in order, but it doesn't really matter. They're just tips, okay? So I like to start, you might say, oh, where am I going to start in this yucky thing, right? Start with the larger subscripts. Start with the compound with the bigger numbers in it. Now, why do we do that?
To borrow from them to others.
Because if we start with that one, you shouldn't get anything bigger than that, right? If you start with a small one, you say, okay, this one's this. Then you got to go to something bigger. You got to change this one anyway, right? So start with the bigger numbers. And again, if you don't do this, it's not the end of the world. But if you're wondering where to start, start there. Start with compound that has larger subscripts. You guys know what I mean when I say subscripts, right? The numbers on the bottom. Okay? So that's a good starting point. Now, if an element exists multiple times on the same side, for example, oxygen is everywhere. And there could even be an oxygen right there. It's just everywhere. Save it for last. Otherwise, and let me tell you, sometimes you want to do it first. But most of the time, if you save it for last, it's going to help you. So again, if you don't remember these tips and tricks, not the end of the world. Okay? So if an atom appears, or an element, I should say, multiple times on either side, then save for last. This little symbol right here that I write, I write this a lot. It kind of means then, or okay, because of this, do this, right?
Save for last.
I had one student ask me, why did you put a smiley face on there? But anyway, it's just an arrow, okay? Saying, therefore, do this, okay? Any questions on that one? And we'll go through examples where we do this.
In the top examples, you can go to.
Yeah, we'll do examples to where you understand what I'm talking about. So maybe just write these down for reference. Okay? If an element exists all alone, like for example, this oxygen is all by itself, then save it for last. So diatomic molecules count as being alone, right? Save for last. Good? Okay. If we can balance the equation using fractions or decimals, then do it. We just can't leave it that way, okay? If you can balance the equation using fractions, and again, decimals are a type of fraction, right? Fraction of a whole. Decimals, okay? Using fractions, then do. But cannot keep it that way. How do we fix it once it's balanced with a fraction?
Convert, keep it that way.
Then multiply every coefficient by the same whole number. A whole number that will get rid of the fraction. If we have, for example, 1/2, what are we going to multiply 1/2 by to get it to be a whole number? 2. By its denominator. But if it's balanced with fractions, we got to multiply everything by 2 so that it stays balanced. You with me?
What is it? Is it convert or
Cannot.
can?
You cannot keep it that way. Okay. If a polyatomic ion, or if a polyatomic exists on both sides of the equation, then we can treat it as a single unit. For example, if we have carbonate on both sides, and it will be in a compound, right? Like sodium carbonate or whatever. If we have carbonate on both sides, we don't have to count all the carbons and all the oxygens or whatever. We just say, okay, how many carbonates do we have on the left? How many carbonates do we have on the right? Well, we can only do that if it's the same polyatomic on both sides. Good? Treat as a single unit. Does that confuse you when I say unit? Single entity, maybe? A single component? Maybe I should call it that. Single component. One more. And again, these are just to help us to balance it. Okay? Last one. If there's an odd number of one element on one side and an even number on the other side, use least common multiple. Ugh, that sounds mathy. If odd amount on one side and even amount on other side, use least common multiple. So for example, if I have one side has 2 carbons and the other side has 3 carbons, what's the least common multiple of 2 and 3? 6. Make so that I have 6 carbons on both sides. Make sense? Yeah.
Can you scroll down?
Yeah, sorry.
So does that mean like on the left side you times it by 3 and the other side you times it by
That's right. You put a 3 coefficient and a 2 coefficient. Yep. And when we're done with the balanced equation, it should be written in simplest whole number. So if we can divide all the coefficients by 2, then do it. Okay? Okay. Great. That's a bunch of information. Doesn't mean anything until we try it, right? Anybody need more time before I move on to an example? All right, let's do this first reaction we did with propane. We have C3H8 plus oxygen gives us carbon dioxide and water. So you don't have to show work, ladies and gents. You don't. I'm just going to show you what I'm doing here. So on the left side, I have carbons, hydrogens, and oxygens. On the right, I better have the same 3 elements, otherwise something's wrong. Okay? So I'm just showing you what I'm doing. When I do this for real, I just look at carbon and count and make sure it has the same on both sides. Look at hydrogen, make sure it has the same on both sides, and so on. But if you like showing your work because it helps you, then do it. Okay? All right, so let's start with carbon. How many carbons do I have on the left side? Here's the sides, right? This line separates the sides. We have 3 carbons on this side. How many do I have on this side? 1. Does everybody understand 1? That 2 only goes to the oxygen, right? Because if it's in parentheses, then it goes to everything in the parentheses. Okay? So that means we need a coefficient where? In front of what compound? Carbon dioxide, right? What coefficient should we put there so that it has the same on the left? A 3. So now I can say, okay, they're the same. Rather than writing how much we have and then change it, I'm just going to make sure it's the same. And then this is just to show me that I have the same, right? So carbon's good. Does that make sense? But I just put a 3 in front of that carbon dioxide. That changes what? Oxygen. Should I count oxygens next?
No,
Because it appears everywhere, right? That's that trick that says, okay. And why did I start here, guys?
because that's the most.
Largest numbers, right? Largest amounts. That's why I started right there. Did I have to start right there? I really didn't. But that's a good place to start. If you don't know where to start, you can always just start at the left, right? Move on. Doesn't matter, okay? So now let's count hydrogens next. Because we want to save oxygen for last because it's all by itself right here. And there's 2 places where oxygen appears on the right side. Okay? So hydrogen has how many on the left? 8. How many on the right? Oh, so we need a coefficient right here. What do we need? 4. 4 multiplied 2 gives us 8. Now we have 8 on both sides. So far, so good, yeah? Y'all with me? Now we can do oxygen. Which side should we count first? The left side has oxygen all by itself. Let's leave that for ultimate last. Why is that? Because if that's the last thing we change, it doesn't change anything else. Does that make sense? Why do we do that? So I'm going to count how many oxygens we have here. How many oxygens do I have in the carbon dioxide area? 3 times 2, that's 6. Plus, how many here? 4, because the 2 goes to the hydrogen only. You with me? So in water, there's 2 hydrogens to 1 oxygen. So it's 4 times 1, which is 4. That's a total of 10 on the right side. So what number do I need to put there so that I have 10? A 5. 5 multiplied 2 gives us 10. Everything works out, we're done. It's in the smallest ratio, smallest whole numbers possible. We can't simplify, so we're done. How do you feel on that? Not too bad? So we used 3 of those tips and tricks just on that one equation. Any questions on that? Okay, let's do another one. How are you going to get good at this? You do a million of them. No, not literally, but okay. So if we have iron plus, let's say we have iron 3 chloride breaks down into iron and chlorine. What formula am I going to write for chlorine? Cl2. Because it's a diatomic molecule, right? And for these balance equations, I'm just going to give you the equation. But later, we'll have to know that, right? Okay. Do you like me showing my work?
Yes.
Okay. So let's continue to show work. We have iron and chlorine on both sides. That's good. Where should we start? Chlorine. There's 3. That's the biggest number, right? Start with chlorine. There's 3 on one side. How many on the other side?
2.
So we use what? Least common multiple. What's the smallest number that 3 and 2 go into evenly?
6.
6. So we're going to put a 2 in front of this one to make 6 chlorines. And we're going to put a 3 in front of this one to make 6 chlorines. You with me? Okay, we just changed how many irons we have. How many irons do we have on the left?
1.
2. You with me? So we need a coefficient of 2 in front of that iron. Did I say fluorine again? Iron. It's iron. So we have 2. And we're good. So sometimes we'll leave the coefficient 1. Not a problem. But we just do this until it's all balanced. Yeah.
So once it's balanced, that's like the true equation of like what's
Yes.
going on.
And why do we do this? Who cares? So that we can make better predictions, better calculations to figure out, well, if we're mixing these 2 substances together, we want to know how much of this substance it makes. Well, if we need 10 grams of this substance, can we figure out how much of these substances we need? We can. But not if it's not balanced. Got to have it balanced first. And what's the purpose of doing that? Making predictions? So we don't have a lot of waste. A lot of waste means a lot of money that we spent we don't need to, right? Okay, that's the purpose. Yeah, Chad.
I guess my question is like theoretically, the coefficient 2 iron 2 Fe, that's the same thing as Fe with subscript 2, right?
No, it's not.
It's not.
Nope.
Why is it not?
Why is it not? Well, it's the same as counting,
Yeah,
but
they're both 2 irons, right?
but you cannot just say, okay, we have, I'll just put a 2 right there. But it's still 2 irons. 2 iron atoms, right? So yes, that's true. But
But for this,
never change the subscripts if they're,
oh, right.
right? Yeah.
I guess just like conceptually,
Yes.
it's the same thing.
Yes. Uh-huh. So here we have 3 times 2, that's 6 chlorine atoms, right?
And that'd be the same as chlorine 6.
It would be, but there wouldn't be such a thing as chlorine 6. But yes.
I see, okay.
Okay. That's why you don't change the subscripts, otherwise you're going to end up with stuff that doesn't even
I see,
happen. Okay?
Can you give another example?
Yes, we'll do a few more examples. Okay? So far, that was the last tip and trick that I gave you. Let's do one that says, okay, if we can balance using fractions, then do it. So let's do it. Here we go. So if we have butane, the stuff in your cigarette lighters, burns with oxygen to make fire, and the products are carbon dioxide and water. That looked like when I burn propane, right? If you burn any carbon hydrogen compound in oxygen, we will always get carbon dioxide and water, always. Guess what another carbon hydrogen compound is? Wood. When we burn wood, we get the black smoke, right?
Yeah.
That's carbon dioxide. And if you put your hand over it, not directly over, you're going to get burned, right? You'll get a little bit of condensation, right? Water comes off of it. Good? All right. So let's balance this. We got carbon, hydrogen, and oxygen. Where should we start? Either hydrogen or carbon, right? Start with this compound right here because it has the largest numbers. It really doesn't matter which. I like to start with carbon because it's first to the left or right, but it doesn't matter. Let's start with hydrogen. No big deal. How many hydrogens do we have on the left? 10. So what coefficient needs to go right there? 5. Okay, so we have 10. Let's use a different color. So we have 10 and 10.
You put it on carbon.
Uh-oh. That's because I normally do carbon first. Okay, 10 and 10. Thank you. All right. So now let's do carbon or oxygen next. We're going to save oxygen for last because it's everywhere, right?
Multiplied by 2 to get 5, 2, 5 is 10.
Yep. 5 multiplied 2 because there's 2 hydrogens in 1 water, right? We have 5 waters. That makes we have 10 hydrogen atoms.
It's based on the water,
Yep.
hydrogen atom.
Yep.
Multiplied.
Good?
Least common.
All right. Now carbon, we have 4 on this side. So what number goes in front of carbon dioxide?
2.
Let's try a 4. Why a 4?
To make it 8.
Does that 2 go to the carbon, guys? No, it does not. Never. The only time it goes to that carbon is if there's parentheses. You with me? Good, that's not okay. All right, so we have 4 carbons on this side, and now we have 4 carbons on that side. So far, so good. Now we do oxygen. Where should we count first? Right side or left side? Right side, it's all balanced, right?
Oxygen, they're balanced.
But it's not 2 oxygens. Let's see. Let's count the right side because it's already balanced, right? So how many carbons do we have right here in this first substance?
8.
8. How many do we have in the second substance? 5.
You mean oxygen?
Sorry. Oxygen. Gosh. I'm sorry, guys. I do that so much. Just learn to read my mind and you'll be good, right? Maybe you won't be. Okay. You're crazy in there. All right. So we got 13 oxygens on the right side. Now, what number needs to go in front of that O2 to get 13? 13 halves, right? Or 6.5. You can just say 6.5 if you want. But if we do that, are we balanced? Yes, we are. But we cannot leave it that way. So what are we going to multiply everything by? We multiply it by 2 to get rid of this denominator, right? But even if we had 6.5, we could see if we multiplied 6.5 by 2, that's going to give us a whole number, right? So you can use decimals, that's okay. But I think it's easier. Okay, I need 13. 13 divided 2 times 2 is just 13, right? Okay. So now I got to multiply everything by 2. And if I do that, so that I don't make a big old messy equation here, I have 2 times 1, because the coefficient of butane is is 1. C4H10. If I multiply 13 halves by 2, I get 13. If I multiply 4 by 2, I get 8 carbon dioxides. And 5 by 2 is 10 waters. It's still balanced because we multiplied everything by the same number. Good?
Question.
Yeah.
So, can you scroll up just a little bit? When we did the oxygens, on the right side, we have 8 plus 5 because,
4 times 2 is
so
8.
4 carbons, but
8
why is it-
oxygen.
why does that 4 go, like, multiplied oxygen?
This says there's 4 carbon dioxides.
Oh, I see.
This says there's 13 halves oxygen. This says there's 5 waters.
And so, okay, so because there's 4 carbon dioxides, that implicitly means there's 4 oxygen.
Yeah, if we draw 4 carbon dioxides,
4 times.
it looks like that, right?
So that'd be 4 times the
Yeah, there's 4 carbons and 8 oxygens. Thanks for asking. I kind of described that, but sometimes you need to see it, right? Are we good? Okay, so now I have a balanced equation. Done. And notice all these coefficients, it doesn't have a common factor, right? Besides 1, 1's okay. We can't divide anything out of it to simplify it. I always have things in simplest form. Why? Because easy's better, right? Simple's better. Any questions on the fraction one? Okay. One more example, and let's see. Yeah, one more example, and then that kind of shows all the different types that you'll have, and then you just practice these. And I gave you a worksheet with a lot of practice on it. Any questions so far? Okay. Let's move on to our last one. Ammonium sulfide. What's this called?
Magnesium nitrate.
Good, magnesium nitrate. Gives us magnesium sulfide and ammonium nitrate. Now, here we see we have ammonium on both sides, and we see we have nitrate on both sides. So when we're writing these things that we have, we can count ammonium as 1 unit, magnesium nitrate as 1 unit, and sulfur. Notice I didn't put the charge. We don't care about the charges because they're in compounds. You with me?
And last one is sulfur.
Sulfur. And we have ammonium, magnesium, nitrate, and sulfur on both sides. Do you have to use this trick, guys? You do not. If you want to just count all the nitrogens, all the hydrogens, all the sulfurs, all the magnesium, that's okay. It's still 4. But I find that it's most of the time it's easier to do it this way. But that's me. If this confuses you, don't do it. Okay? So let's do this. Where should we start? Ammonium. There's 2 of them. The other one that there's 2 is nitrate, so either one of those would be okay to start with, right? Okay. So how many ammoniums do I have on the left? 2. How many do I have on the right? 1. So I have to put a 2 right there. You with me? Okay. I just changed nitrates, so let's do nitrates now. How many do I have on the left? How many do I have on the right? Oh, that's good. Okay, good. How many magnesiums do I have on the left? One. How many on the right? One. Sulfurs? One of each, right? That one looked a little, but it's not too bad, right? So I don't know if that was any easier for that particular one, but do you see the tip and trick on that, guys? How you use that? Yeah. Chad.
So the 2 coefficient on the right side in front of ammonium nitrate applies to.
Goes to the whole entire compound.
That's why there's 2.
Yep.
Okay.
Yep. Does everybody understand this? All right. Let's take a few minutes, 5 maybe, practice these. I brought some demonstrations today. We might not get to a lot of them, but I'd rather you get good at it. So on this worksheet you picked up, let's do section 1. And I drilled a hole in one of the ones. This one should be zinc.
Number 1.
On section 1, that one, the middle hole in the page. I chopped out zinc. Should be just zinc metal.
Zinc.
Look on there if there's one that you want to do together. Let me know. If you want to just try it. Yeah.
We do the FeO plus O2.
Yeah.
Goes to, or produces Fe2O3.
Which one?
It's the second one.
Oh, second one.
This one here?
C2H.
Okay. So let's do this. We have iron and oxygen on both sides. Where's a good place to start? Fe2O3, those are the biggest numbers, right? Okay. Should we start with iron or oxygen? Should we start with oxygens to show you that it really doesn't matter where you start? Because it doesn't. Iron would be the best. Why? Because oxygen appears everywhere, and it's all alone right there, right? But let's do oxygen. How many oxygens do we have on this side?
3.
How many do we have on this side?
1.
Okay, 3 and 3. No big deal. Right?
How we have on the side 3?
We have 1 here plus 2 here. You see that?
Yes.
Okay. What about irons? 2 on this side. We just have 1. So what we need a coefficient, right? We're going to have to change the oxygen anyway. No big deal. We can still do it, right? So how many oxygens do we have on the right now? Right 3, left 4. Still not working, right? So let's write that. We got 3 and we got 4. Still not there. So gosh. This is always going to be even because we got a 2 there. That's always going to be even because we have a 2 on oxygen, right? No matter what number we put there, it's going to be even. Right now, this is always going to be odd. How do we make it even? Because it's always even on this side. Put a 2 right there. Multiply anything by 2, it makes it even every single time. Do you get that?
2 times 2 is 4.
So then we say, okay, now we have 6 oxygens on the right,
And 4 on the left.
but we have 4 irons on the right. You with me? So that means, we need to have 4 irons on the right. And now how many oxygens do I have on the, sorry, 4 on the left, 4 on the right. How many oxygens do I have on the left? 6. Oh, that was a little clunky, right? But we eventually got it. If you just keep going, don't give up.
To make balance both sides like equation.
Yeah.
Could you do the first one?
Yeah. Okay, we got aluminum plus sulfuric acid gives us Al2SO4 with a 3 plus hydrogen gas. Okay, what compound, what substances do we have on the left? What components?
Aluminum, sulfate, and hydrogen.
There we go. And we should have the same on both sides. Make sure we do. Okay. Where should we start? Maybe that one right there, yeah? That one has the largest numbers. You want to start with sulfate?
Yeah.
Great. We have 3 on the right, so we only have 1 on the left. So we better put a 3 right there. You following?
Yeah.
Okay, since we just changed that, maybe we could just start with hydrogen next.
Yeah.
We have 6 hydrogen on the left, so I need to put a 3 right there so that I have 6. Okay, everything's good. Now do the aluminum. We have 2 on the right, so I need to add a 2 right there so that I have 2 on the left. Just going back and forth. Sometimes that's all it is. Like on that last example, we just had to keep changing, but we eventually got it.
I think
Yeah.
what threw me off is when I wrote out each one on each side, I wrote H2 instead of just H.
Yeah.
Like that threw me off. So.
Yeah, you can only do that if, so,
It's probably something
you,
with one
yeah,
thing.
you can only do that with polyatomic ions. We good? And again, you don't have to do that. You can just say count all the sulfurs and all the oxygens. That would give us 1 more to have to count, but not the end of the world. Should we do it without polyatomic ions? Anybody want to do that? Balance the same equation without saying, okay, count the polyatomic ion sulfate. Okay, let's do it. Okay, so Al, H, S, and O. Okay, we can start the same place. Let's count the oxygens first, because there's how many on the right? 12. So that means we need to put a 3 right there. Now we have 12. That same thing we did before? Was. Okay, it really doesn't matter. We have 3 sulfurs, 3 sulfurs. Good. That's basically, we did sulfate in 1 step instead of 2 steps. But we could still do it, right? And then we come over here, okay, now we have 6 hydrogens. So we put a 3 here to make 6 hydrogens. There's 2 aluminums, so we put a 2 here to make 2 aluminums. Done. You really don't have to follow any of those tips and tricks. Saved us 1 step using it. That's it. Okay? So if you can't remember those tips and tricks that I gave you, you can still do it. Okay? Any others you want to do together? Or do you want to just try some? Maybe I'll put the answers up on the board so you can kind of see. Would that be useful? I would try these before looking at the answers, just so that you get practice doing it. But the key here, guys, is practice. Just get it down. If you have a question on one, let me know. Yeah?
On the second one, how come it's?
This one right here. Whoops. This one right here.
No, the one on the bottom.
Okay.
Yeah. How come it's, what is that, 5 oxygens on the right and 7 oxygens on the left?
Let's see. 4 times 2 is, or sorry, 2 times 2 is 4. 3 times 1 is,
Sorry.
no, that's,
They can just write them like that.
and guys, sometimes it'll happen to where you're just like, this isn't working, I can't figure it out. What's the best step to do next? Erase everything and start again. Start somewhere else. Just get a fresh start.
4 plus 3 is 0.
Does that make sense?
Oxygen. How we can know what the 3 oxygen?
Because there's 3 water molecules, and every water molecule has 1 oxygen. Do you see that?
How we put it?
Why do we put a 3 there?
Yeah.
To make it balanced
With that one.
with this side, yeah. You following, everybody? Okay. We'll probably do the chemical reactions next time. So that's all I have for you. If you want to stay and ask more questions, if you want to stay and practice for a minute. They're easy for you? Good, good. But guys, this is just a step getting to where we're going.
Where are we going?
We're going, hopefully, on vacation. No. Go where? Oh, yeah? Take care. Thanks.
I told our teacher and this campus area have a good truck.
Yeah. Explain everything.
It's called explain everything?
Yep. There is a free version, but if you have a lot of people, because you can kind of, I could have somebody from a different state sharing this and writing on with it. With that version, you have to pay, but if you're just using it for notes, probably get a free version. Yeah. And the cool thing with this is you have infinite screen.
Exactly.
Or you can just go to the next page. You can add another page,
Yeah.
or you can just keep working on it. Thank you. Take care.
The chapter for today, I have to go to exam 3.
For what?
Print the chapter. Print the chapter.
Yeah.
Exam 3.
Yep. Now we're on exam 3,
And then I can.
and it's just like
We
the other
just
one.
study chemical bond. That's it. Today we study. Next time we
This
study.
right here is a video lecture.
This one is video.
If you wanted to watch it, but
Yeah, but this is today we study.
yeah,
Thursday we study this
Thursday
oxidation,
we'll probably do both of those.
oxidation and more. Okay. The reason
Yep.
I'm sure I need to print this to read and also read in the book. A video watching is good, but you are explaining